Taylor asked me about some transposition of electrical trade equations, and I'll just to give a brief explanation if I can. So all electricians remember the VIR triangle where you cover the unknown one. V equals I times R, of course. I, the current, equals volts divided by the resistance, and the resistance there equals the volts divided by the amps, of course. So it's automatic transposition there. When we look at the actual process of transposition used in that triangle, if we start with the Ohm's law equation of R equals V divided by I, voltage divided by current, we can, if we want to make I the subject of the equation, then we want to move that to the left-hand side of the equal sign. Because it's volts divided by, or V divided by I, we can multiply this by I, and the two I's cancel out. But because we've multiplied one side by I, the other side of the equation must also be multiplied by I. So this side becomes I as well, multiplied by I. So these two I's cancel out, and then you're left with the subject of the equation where voltage equals the current times the resistance, or voltage equals current times resistance. Similarly, if we wanted, we start with our R equals V on I, and if we just want the voltage as the subject, multiply both sides of the equation by I, keep it in balance. These two cancel out, you're left with the voltage equals the current times the resistance. If we want, similar thing can happen with the power equation with the PIV triangle, of course, where power equals volts times amps, or the current equals the power divided by the volts, or the volts equal the power divided by the current, of course. So if we substitute into this Ohm's law, the VIR triangle, we end up with the other power equations of P equals I squared R and P equals V squared on R. So similarly, if we wanted to transpose, say, this equation for R as the subject of the equation, we start with P equals V squared R, V squared divided by R, to get rid of that from that side, multiply by R, and that puts R before the equal sign. These two cancel out, so V squared is equal to R times P. We want R as the subject, so we divide out P from this side, they cancel out. Divide out P from this side as well to keep it in balance. Always remember to keep it in balance. Plus 1 to this side, plus 1 to that side, keep the equation balanced. So R would be equal to V squared divided by P when we've completed it. So the basic rule of transposition is to do to one side of the equation whatever you do to the other side of the equation. If we look at, say, another one of, just a little E equals BLV, the induced voltage equation, and we want to find V, the velocity, so we can simply divide out the B and the L, keep it in balance, divide out B and L, and those two cancel out, so therefore you're left with the velocity equals that voltage divided by the flux times the length. So again, balancing the equation. If we had, say, P equals 2 pi nt divided by 60, the mechanical power equation, and we want to find the subject of the equation as N, remember we've got to get that to the left-hand side of the equal sign. So get everything on the top line first, get rid of this divided by 60 from that side of the equation so we can multiply it out, but to keep it in balance we've got to multiply that side by 60. these two cancel out, so we're left with 60 times P equals 2 pi nt. Remember, we're looking for n as the subject, so these are all multiplied, of course, so we can simply divide out 2 pi and t, which cancel out, and leaves n by itself. Balance the equation, keep it in balance, 2 pi t, so therefore the n, the speed, is 60 times p divided by 2 pi t. And you can complete your equation or your calculation after the transposition. If we looked at, say, simply the impedance triangle, where z squared equals r squared plus x squared, and we wanted to find, say, the value of x only, then we'll get rid of the squared signs. So if we square root this side and square root that side is balancing the equation, the square value and the square root cancel out, and that's left balanced in the equation because the other side's square rooted. So therefore your z is equal to the square root of r squared plus x squared. If we're looking for x as the subject, is what we're after, wasn't it? So we'll go back to z squared equals r squared plus x squared, and we're looking for x as the subject. Of course, this is plus r squared. We can minus r squared from both sides, so to put it on the left-hand side. So minus r squared leaves x by itself. So plus r squared minus r squared cancel out. Balance the equation, so z squared minus r squared is equal to x squared. So therefore x is equal to the square root of z squared minus r squared. So again, it's all just about doing the same thing to each side of the equation until you get the subject of the equation that you're after. A common one that pops up might be your three-phase power equation, volts times amps times cos theta. And root 3, of course, in three-phase power, so commonly asked to find what the current is, given the values of voltage and power and power factor. So because they're all multiplied by, simply divide out the root 3, the v, the cos theta, balance the equation, divide this side by the same, root 3v cos theta, and you're left with these cancelling out. So you're left with I by itself, so therefore I is equal to P divided by root 3v times cos theta. Then the transposition of your three-phase power. Of course, the same thing happens with addition and subtraction. You know, your series resistors, RT, R1 plus R2 plus R3. If we wanted to find R3 for the subject, these are all added together, so we can subtract these two. We can factorise it and subbracket them and subtract that from both sides of the equation. So R minus R1 plus R2. R2 in brackets, so these two would cancel out. Balance the equation, RT minus R1 plus R2 equals R3. So technically R3 equals RT minus R1 plus R2. Gets a little bit more tricky, I suppose, if you're doing the parallel resistance equation, 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. Again, if we wanted to find R3 as the subject of the equation, similar process, balance the equation each time you change it. We want R3 to be by itself at one stage to be the subject. So want to get rid of that lot there. So we subtract that from both sides of the equations. So 1 over R2 minus 1 over R1 plus 1 over R2 is equal to 1 over R3. because we've minused it from this side of the equation, so it's cancelled out. If we want R3 as the subject, we've got to get it up to the top line rather than the inverse. So let's go through that process step by step. So we multiply both sides of the equation by R3. So R3 times, parentheses, 1 over R2 minus 1 over R1 plus 1 over R2, bracket, is equal to 1, because these R3s cancel out on that side of the equation. Now, because this is R3 times that value, if we divide both sides of the equation by the parentheses, 1 over R2 minus 1 over R1 plus 1 over R2 is equal to 1 divided by 1 over R2 minus 1 over R1 plus 1 over R2. So this lot cancels out, of course, on that side of the equation. So you're left with R3 up here, R3 being equal to 1 over RT minus 1 over R1 plus 1 over R2. So it gets pretty tricky when you're doing things like that, but still, whatever you've done to one side of the equation, keep it in that balance, and you won't change the effect of it. So hopefully that helps.